In this lesson, we're going to be talking about proportional relationships. And in lesson 12, we learned about solving problems involving percents with proportions. In this lesson, we're going to solve percent problems that involve increases and decreases. And let's look at this problem to discuss it more. In May, Susanna earned $40 from pet sitting. In June, her earnings increased 200%. How much does she earn in June? So we know she began by earning $40, and then it increased, so that amount she started earning went up. So we know that what she earned in June would be more than $40, but we want to know specifically how much would that be. And we know that it's 200% more, but we want that dollar amount. So we can use what we know about the $40 from May and the 200% increase to calculate how much she earned in June. Let's answer some questions to help us investigate this problem. First, consider 100%. What is 100% of $40? Remember, 100% is the whole thing. So 100% of $40 is $40. Next, how does 200% compare to 100%? 200% is twice as much, or 100% more. And remember, when we think of twice, we know that means times 2. How much is 200% of $40, and explain how you know? Well, 200% of $40 would be $80, because 2 times 40 equals 80. And twice 200, 100 is twice the amount of 200%. So 2 times 100 is 200, 2 times 40 is 80. How much is 200% more than $40? So remember, in May she earned $40, and then it increased by 200%, which is, we now know, $80. So how much is 200% more than $40? $40 plus $80 is $120. So 200% increase would mean she would earn $120 in June. F wants you to explain what it means when a value increases by 100%, and what it means when a value increases by 200%. Go ahead and highlight that problem. And if you'd like to, you can go ahead and pause the video and answer it now, or come back to it in just a minute. Let's find out a little bit more about percents that increase and decrease. When a quantity changes over time, it is often useful to compare the original quantity and the new quantity. Comparing the original to the new by describing the difference or the amount of change. And a lot of times we do that as a percent. This is called the percent change. And it is the ratio that compares the amount of the change to the original amount. If you notice that word in there, ratio. So we can use words to write our definition of percent change as a ratio. It compares the amount of change to the original amount. So you can see how they've written that as a ratio, the amount of change to the original amount is the percent of change. And we say percent change because sometimes that change is an increase and sometimes that change is a decrease. The percent change will be an increase when the new amount is greater than the original. The percent of change will be a percent decrease when the new amount is less than the original. So if your amount goes up, it's a percent increase, and if your amount goes down, it's a percent decrease. And we can use ratios and proportions to find Susan's June earnings, just like we did on the previous page. So you can see, I want you to jump and take a look at this second proportion. So they've written a proportion comparing the amount she earned on the left to the percent she earned on the right. So the 100% was what she made in May, $40. The 200% is what she made in June, and then we don't know how much she made in June. So we use that variable X to represent what we don't know. And then you can cross multiply and divide to get that $80. But it was an increase, so then you have to add that back, that $80 back to the original to get 120. If we were to draw a diagram, so originally she earned $40. Well, then her new amount, so this was May, her new amount was 200%, so twice that. So we could draw a diagram that is 100%, 200%, so double the length. And that shows what she made in June. So you can see here we're at 100%, and then here we're at 200%. So this first box, this first section is $40, and then the second set is another $40. So 40 plus 40 is that 80. But then again, remember, you have to add that back to the original to get the 120. Now, another way we can look at these, so we have percent change, percent increase or decrease. We can look at percent error. So percent error is the ratio describing how far an estimate is from the actual. So again, we have that word ratio in there, so we can write the ratio of the amount of error over the actual amount. So an example would be if you estimated that your book is 11 inches long. So that 11 inches is your estimate. But really, it's 10.87 inches long. So that's the actual. The percent error, so using that ratio, the percent error would be 0.125 over 10.875. Well, you might ask, where did you get that 0.125? I thought it would be 11. Remember that top number, that estimate, that is the amount of error. So to get that amount of error, I'm going to come over here to the side. We subtract what we thought it was, our estimate, minus what it actually was. And when we do subtract, we're going to have to borrow from all of our neighbors. And we get 5, 2, 1, bring down your decimal, 0. So that's where we get the 0.125. So remember, you want to subtract your estimate and your actual to get that top number. And then when we divide those, that's where we get 1.1%. Go ahead and highlight number 1, your reflection.